All right. Just want to check with everybody. Everybody can see this. No problem. Awesome. All right. So let's go through this real quick, real quick. All right. So we're gonna be come in, come in. How are you? Long time no see. How you been? You're collecting them?
Yes.
I wanted this. All right, bring it back to me. Can you do that for me?
So
All right, appreciate you.
we just need to update the Excel sheet.
Got you, got you. All right.
That way.
Thank you, thank you. If you see any other students, send them my way.
I-
Yeah. All right, so we're gonna be simplifying expressions with absolute values. All right. Again, if you know this already, just knock out the worksheet. All right. So a negative number, right, is a number that is less than zero, right? So the negative numbers are to the left of zero on the number line, as you can see right here. So this is a number line, right? In the middle, we have zero. To the left of the zero are negative numbers. To the right of the zero are positive numbers, right? So you may have noticed also that on the number line, the negative numbers are a mirror image of the positive numbers. So what that means is that there's a negative one, there's a positive one, there's a negative two, there's a positive two, right? Um, because the numbers two and negative two are the same distance, that's the key word there, distance from zero, each one is called the opposite of the other. The opposite of two is negative two, and the opposite of negative two is two. All right. So let me define this word opposite. All right. The reason why I'm defining it is because it's like I'm trying to give you guys like a mathematical definition of the word opposite, even though we have like an English definition in our head. Right? I just want to like broaden our knowledge a little bit, right? So the opposite of a number is the number that is the same distance from zero on the number line, but the opposite side of zero. All right. So this is what opposite means in mathematics. All right. Let me show y'all an example. So let's say like here, right? This is a number line, zero's in the middle, right? Three, positive three is 3 units away from zero. And also negative three on the other side is 3 units away from zero. All right. This makes sense, or am I losing you guys? Makes sense? All right. Good. All right. So opposite notation, all right? Negative a, for example, means the opposite of the number a, right? So the notation negative a is read as the opposite of a, right? When I say a, I mean any number, right? Just using a variable to represent any number. Hmm? Right? So we saw that numbers such as three and negative three are opposites because they are the same distance from zero on the number line. They are both 3 units from zero. The distance from zero and any number on the number line is called the absolute value of that number. All right. So that's what absolute value is. Well, let me give you the formal definition. All right. So the absolute value of a number is its distance from zero on the number line. So the absolute value of a number n is written as absolute value of n, and the absolute value of n is greater than or equal to zero for all numbers, right? So absolute values are always greater than or equal to zero, right? Now, in computer science, sometimes you might want to actually use this to get a number that is always positive. Say you have a variable that fluctuates, it could be positive or negative, but you want whatever answer that comes out of it to be positive, you would use the absolute value function to actually give you that. Right? So that's how you can use this. All right. So once again, it's just measuring the distance that any number is from zero. That's why the absolute value of -3 is +3, and the absolute value of +3 is +3 as well. Mhm. Just want to give y'all a visual example real quick before we move on. All right. So for example, -5 is 5 units away from zero. So the absolute value of -5 is equal to 5. And 5 is 5 units away from zero. So the absolute value of 5 is equal to 5. As you can see in this number line right here, right? Zero's in the middle, -5, 5 units away. +5, 5 units away. All right. So the absolute value of a number is never negative because the distance cannot be negative. There's no such thing as negative distance, right? The only number with absolute value equal to zero is the number zero itself because the distance from zero to zero on the number line is 0 units. All right. Just build on the vocabulary a little bit, then we'll get to an example. Right? So we now add absolute value bars to our list of grouping symbols. So when we use when we use the order of operations, right? First we simplify inside the absolute value bars as much as possible. Then we take the absolute value of the resulting number. So what this means, you guys remember PEMDAS? Please excuse my dear Aunt Sally, right? So what I'm trying to say is that whenever you're dealing with the absolute value, right, you're gonna treat that as if it was a parentheses, right? So you do what is so excuse me, you do whatever is in the absolute value bars, right? Yeah, bars, right? Before you work on the outside, right? Go ahead. Right. Those like vertical lines right there. Yeah. Good stuff. Good stuff. So just to recap real quick, right? What are some of our grouping symbols? All right. So just showing you guys this. This also helps in computer science too, right? So like when you're trying to do certain equations and stuff, like you'll see that in the calculator portion of the workshop, where on older model calculators, we have to actually like use a lot of grouping symbols in order to get across what it is that we actually want, you know? So we have parentheses, all right? We have the braces. I call these curly braces, all right? We have brackets, right? The square brackets. And then we have absolute value bars, right? So these are our grouping symbols, right? If you have some type of expression that's inside in between them, you do that first before you do the outside work, right? All right, let's do an example real quick. What should I do first here? What do you guys think? The parentheses, okay. So what is it gonna be? Tell me what to write. 4, right? So this would be 24 minus the absolute value of 19 minus 3 parentheses times 4, right? What should I do next? Hmm? Do the what? Similar problems are on there. Yeah, similar problems. 3 times 4, right? So this would become 24 minus the absolute value of 19 minus 12, right? Everybody good with this? Questions? All right. What should I do next? What should I do next? Right. So I do the inside, right? So 19 minus 12. Let's go give me my 7. So 24 minus the absolute value of 7. And then now I can deal with the absolute value, right? 7 is how many units away from 0? 7, right? So this becomes what? 24 minus 7. And then just do the regular math, right? What is that? Is it like 17 maybe? Something like that? 24 minus, yeah. And then that's it. Right? Me personally, I kind of like to box my answers and then highlight it. Just my little preference, you know, that's how I like to do it. Yeah. But yeah, that's it in a nutshell. That's how we do this. All right. Would y'all like to try one? Mhm. I got you. All right, this is similar to what we just did. Go ahead, try it. Anybody need paper or anything? Or are you guys good? You want scrap? Mhm. All right. Everybody good? Or are you guys still working? All right, take your time. Take your time. No, good? All right. Let's take a look. Let's take a look. All right. So the first thing I want to do is which one? Parentheses, right? So this is going to become, oops, let me get my pen. Always make that mistake. So 19 minus absolute value, 11 minus 4 times was 3 minus 1, 2, right? And then we're going to do absolute value. What's next after that? Good, good. So this becomes 19 minus absolute value of 11 minus 8, right? What should I do after that? I'm sorry? Right. So now we have 19 minus absolute value of 3. Good. And the absolute value of 3 we know is 3, right? So this becomes 19 minus 3. So then let's call that what? 16. All right. And then, of course, I like to highlight. No pressure. Y'all have to, but it's just my preference. All right. I feel like I should have something else here. Mm, yeah, I don't even need this. I'm gonna take that out. Don't mind me real quick. I'm just trying to pick something else real quick. Blue, green, yellow, something dark. I have a red, I have a purple. I have my rainbows. Da, 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 da. Don't mind me for a second. Do this gray. Put that here. All right, I like that. All right, sorry about that. Okay. So I feel like you guys are picking this up. So like pretty well. So let me just move on real quick. Even though we just did this, let's just humor me for this section, right? So we're going to be adding and subtracting integers, right? So far, we have only used the counting numbers and the whole numbers, right? So counting numbers are like 1, 2, 3, 4, 5, 6, etc., right? Whole numbers are are numbers like 0, 1, 2, 3, etc., right? Our work with opposites gives us a way to define the integers. So anytime you hear the word integer, right? I'm talking about all of the negative numbers, 0, and all of the positive numbers. All right. So the whole numbers and the opposites are called the integers. The integers are like -3, -2, -1, 0, 1, 2, 3. All right. Questions on this? Good. This is another topic that actually comes up in computer science, right? The different number systems, right? You guys will see that. All right. So just to recap real quick. So integers, the whole numbers and their opposites are called integers, right? So the integers are the numbers like -3, -2, -1, 0, 1, 2, 3, etc., etc. Right? Expanding in both directions. All right, this next section that I'm gonna go into, this is gonna seem a little confusing at first. If you have your own method of adding and subtracting and it works for you, don't take this method. All right? Do your way. If your way always gives you the right answer, that's the right way. Keep going with it. All right? But if you want to see something different, you want to adopt something different, I'm going to show you. All right? So here we go. So most students are comfortable with the addition and subtraction facts for positive numbers, but doing addition or subtraction with both positive and negative numbers may be more challenging. So we will use two color counters to model addition and subtraction of negatives so that you can visualize the procedure instead of memorizing the rules. All right. So this is what we're going to do. So let's set it up. Let's set it up. All right. So we let one color, blue, represent the positive numbers, and the other color, red, will represent the negative numbers. So positive for blue, red for negative. All right. All right, so if we have one positive counter and one negative counter, the value of the pair is 0. They form a neutral pair. So the value of its neutral pair, 1 plus -1, is 0. So we can use counters to show how to add, for example, 5 plus 3, or -5 plus -3, or -5 plus 3, or 5 plus -3. All right. Just an idea. So the first example, 5 plus 3, adds 5 positives and 3 negatives, right? Both positives. So the second example, -5 plus -3, adds 5 negatives and 3 negatives, both are negative, right? When the signs are the same, the counters are all the same color, and so we add them together, right? In each case, we get 8. right? Either 8 positive or 8 negative. So for example, I have 5 plus 3. Notice that both the 5 is positive and the 3 is positive. So we just add them together, and that's how we get 8 positive circles, right? Over here, I have -5 plus -3, right? So now we notice that the 5 is negative, the 3 is negative. So I'm just gonna add them together to get -8. All right. Questions on this? Good. All right. Let's keep it moving. So what happens when the signs are different? All right, so let's add -5 plus 3 and 5 plus -3. All right. When we use counters to model addition of positive and negative numbers, it is easy to see whether there are more positive or more negative counters. So we know whether the sum will be positive or negative. So -5 plus 3, all right? So I have 5 negative circles, 5 red circles, and I have 3 positive circles, blue circles, right? When I put a negative circle and a positive circle together, they cancel each other out, right? So this right here is a cancellation. These two are a cancellation. These two are cancellation. How many circles am I left with? I'm left with 2, and they're red. So that means they're negative. So -5 plus 3 is equal to -2, right? The rule that you would memorize with, or you could memorize with this, is that you keep the sign of the larger number. So you subtract, but keep the sign of the larger number, right? Let's do the flip side, right? 5 plus -3. So I have 5 positive circles, right? All blue, right? 5 blue. And then I have 3 negative circles. Again, when I put a negative and a positive together, they cancel each other out, right? So right here, this blue and red together, that's a cancellation. That's a cancellation. That's a cancellation. So what am I left with? I'm left with 2 blue circles, right? And they're both positive, right? And that's it. Questions on this? No? All right. Let's keep it moving. Let's knock out this example real quick. And please don't feel shy to ask questions. There's nothing wrong here, right? We're all family. So what's the answer for A? This is -1 plus -4. -5, perfect. All right. What about B? B is -1 plus +5. 4, good. What about C? C is +1 plus -5. What do we think? -4, right? So when I have different signs, subtract, but keep the sign of the larger number. So whatever the larger number is, that's going to be the sign of the answer, right? Would you guys like to see another one, or do you feel like you get this? Fine. You want to see another one? No, you good? What about you? You want to see another one? Very good. All right, let's take a look at another one. All right, so I have -2 plus -4. What do we think? -6, perfect. How about B? I have -2 plus +4. +2, very good, right? How about C? A little bit more difficult. I have +2 plus a -4. -2, very good, right? So I subtract and keep the sign of the larger number. And that's it. That's the trick right there. You're welcome. So we will continue to use counters to model the subtraction. Perhaps when you were younger, you read 5 minus 3 as 5 take away 3. When you use counters, you can think of subtraction in the same way. So we will use the counters to show that 5 minus 3, -5 minus -3, -5 minus 3, and 5 minus -3. So now we're getting into subtraction. All right. So the first example, 5 minus 3, we subtract 3 positives from 5, yeah, from 5 positives, right? We end up with 2 positives. So for example, -5 minus -3, we subtract 3 negatives from 5 negatives, and we end up with 2 negatives, right? Each example used counters of only one color, and the takeaway model of subtraction was easy to apply, all right? As you can see here, 5 minus 3 is 2. -5 minus -3, -2. Right? But let's talk about the question that we all want to ask. Right? What happens when we subtract one positive and one negative number? We'll need to use both the blue and the red counters as well as some neutral pairs. If we don't have the number of counters needed to take away, we add the neutral pair, right? So adding a neutral pair does not change the value. It is like changing quarters to nickels. The value is the same, but it looks different. That's all. So let's take a look. All right. So let's model the first number. So we have -5 minus 3, right? So we have our -5, right? And then we're gonna now add our neutral pairs, right? So a negative and a positive, right? We're adding 3 of them. And then what's gonna happen, right? We remove the number of counters modeled by the second number. So what's left over? -5 minus 3 is equal to -8, right? -5 minus -3, right? We have our 5 positive. We have our neutral pairs, which is our positive and negative 3, right? We're taking away the 3 positive, which leaves us with 8 positive. All right. Again, I'm not going to ask you to do counters. If you have your method that works for you, use your method. All right. We don't have to reinvent the wheel if it already works, you know? Try this. Tell me what to write. What's A? Very good. What's B? A little bit harder. No, not 4. -2, right? So here's a trick right here. I have -3 minus -1. A negative and a negative becomes a positive. So this becomes like -3 plus 1. So -2, like that. All right. How about C? Let's take a look at C. -3 minus 1. -4. Perfect. How about D? D is a little bit harder. This is 3 minus -1, +4. Very good, right? For the same reason, a negative and negative becomes positive, so this becomes 3 plus 1, which is 4. Questions on this, anybody? We're good? All right. Let's try another one of these. All right, go ahead. Try this out. All right, try it out. All right. What do we get for A? Very good. What about B? A little bit harder. -2. Perfect. What about C? -10. Very good. How about D? +10. Good. Any questions on this? Anybody? Go ahead. You're subtracting +4. Yeah. Yeah. For the D or the C you're talking about? The C. Yeah. So for C, -6 minus 4, right? Think of it as like you owe me $6 and then now you owe me another $4. So in total, you owe me -$10, right? So when they have the same sign, another way you can also rewrite this, you can rewrite this as -6 plus -4. That's legal. That's the same thing. They're all the same thing, right? Like, so when you have the same sign, you just add them, long story short, right? And then different signs, subtract, and then take the sign of a larger number. So, all right, let's keep moving. So have you noticed that the subtraction of sign numbers can be done by adding the opposite? In the last example, right, -3 minus 1 is the same as -3 plus -1, right? And 3 minus -1 is the same as 3 plus 1. So you will often see this idea, the subtraction property, which is written like this. Show you guys. So here's our subtraction property. So A minus B is equal to A plus -B. So subtracting a number is the same as adding its opposite. All right. This is blocking you? Are you good? You good? Okay. So subtracting a number is the same as adding its opposite. All right. That's subtraction property. Let me show you guys an example. So say I have 13 minus 8 and I have 13 plus -8. All right. Let's take a look at what that would be. It's actually the same thing, to be honest with you. 13 minus 8 and 13 plus -8 will both give you the same answer, right? The top one we know is what, 5? And the bottom one, same thing. This is 5. All right. Let's look at B. So for B, I have -17 minus 9, and I have -17 plus -9, right? Both answers will give me the same thing, right? I believe this is like what, -26? I'm sorry, hold on. It's supposed to be a 7. My mistake. -17 plus -9 and -17 um minus 9. All right. Sorry about that. For C, I have 9 plus 15, and I have 9 minus -15. These are actually the same thing. All right. So one of them is 24, and the other one is 24. Right? For the 9 minus -15, you see how you have two negatives there? That becomes positive, right? So it becomes 9 plus 15. I don't know if this helps, but how I like to think about it, if I'm going to subtract two entities or whatever, right? I need one stroke in the middle to make it a subtraction, right? But if I have two strokes, that means that I could change that into a positive because it takes two strokes to write a positive, right? Just like that. So I don't know. That's how I kind of think of it in my head. If I have extra material, I can make it into a positive. But if I'm lacking in the material, it's just a negative. I don't know. Just my thought. I don't know if that helps. So how about D? I have -7 minus -4, and I have -7 plus +4. Right? Same answer. Right? So this is going to be -3 and -3. All right, questions on this idea? Anybody? Good? All right. Let's look at another example. I'm gonna pick it up a little bit because I noticed that time is kind of against us. We have our lunch break at 12. So we'll just pick this up just a little bit. So I want to simplify this. I have 7 minus -4 minus 3 minus 9. All right. So 7 minus -4 minus 3 minus 9. Right. So what should I do first? Let me think. Parentheses, right? So this becomes 7 minus -7, right? Minus 9. And then negative negative becomes positive. So this becomes 7 plus 9. Excuse me, 7 plus 7 minus 9. Let's call that 14 minus 9. So that's +5. All right. Questions on this? Anybody? It's good? All right. So basically, from here on out, you just use PEMDAS and you're good to go with this. All right. So let's talk about multiplying and dividing integers. So since multiplication is mathematical shorthand for repeated addition, our model can easily be applied to show multiplication of integers. So look at this concrete model to see what pattern we notice, right? We will use the same example that we use for addition and subtraction. Here, we are using the model just to help us discover the pattern. So remember that A times B means add A, B times, right? So 5 times 3 means add 5 3 times. So 5 plus 5 plus 5, which gives us 15. And -5 times 3 means -5, right? Plus -5 plus -5, which gives us a -15, right? So the second one just tells you how many times to add something, right? All right, so the next two examples are more interesting. What does it mean to multiply 5 by -3? It means to subtract 5 3 times. So look at subtraction as taken away, right? It means to take away 5 3 times, but there's nothing to take away. So we start by adding neutral pairs to the workspace. All right, let's take a look. So we have 5 times -3. We're going to take away 5 3 times. So we're going to have 3 sets of neutral pairs, right? And we take those numbers away, and we're left with 15 red, right? On the right-hand side, I have -5 times -3. We're going to take away -5 3 times, right? So I have my 3 pairs here, right? Positive, negative, positive, negative, positive, negative. I'm taking away -5 3 times. What am I left with, right? I'm left with Just the 15 positive blues. That's it. That's again just how to visually represent it. If you have another way that works for you, please use your way. Don't let me confuse you. All right, so in summary, 5 times 3 is equal to 15. 5 times negative 3 is equal to negative 15. Negative 5 times 3 is negative 15, and negative 5 times negative 3 is positive 15. Notice that for multiplication of two sign numbers, where the signs are the same, the product is positive. And when the signs is negative, the product is negative. Right? That's simple. So what about division? So division is the inverse operation of multiplication. So 15 divided by 3 is equal to 5 because 5 times 3 is 15. Right? So in words, this expression says that 15 can be divided into three groups, five each containing, excuse me, five each, because adding five three times gives you 15, right? If you look some other examples of multiplying integers, you might figure out the rules for dividing. So 5 times 3, let's give me positive 15. Um, so 15 divided by 3 is equal to 5. Negative 5 times negative 3 is positive 15. And 15 divided by negative 3 is negative 5. Right? And then negative 5 times 3 is negative 15. So negative 15 divided by 3 is equal to negative 5. 5 times negative 3 is equal to negative 15, or 15 divided by negative 3 is equal to 5. That's it. So it follows the same rules of multiplication regardless of the sign. Right? So that's what that is. Want to give you guys some rules real quick. So hold on. Too far up here. This is what I want to talk about right here. Sorry. We're going to be doing multiplication division of sign numbers. So for multiplication division of sign numbers, if they have the same sign, a negative times a negative is a positive, right? If they have what you call the different signs, a positive times a negative is negative, and a negative times a positive is negative. Same sign, positive answer. Different signs, negative answer. It's for multiplication division, all right, of integers. Let's look at an example real quick. So I have a negative 100 divided by negative 4. What do we think that answer is? Say it again. 4, no. So it can also be written as negative 100 divided by negative 4, right? So a negative divided by a negative is a positive. So our answer is going to be positive. And 100 divided by 4 is no. So, okay, half of 100 is, what's half of 100? 50, right? So then This would be like positive 50 over 2, 25. That's it. That's it. Right? This a good B. 7 times 6, what is that? What's 7 times 6? Very good. How about 4 times negative 8? What's that? I'm sorry. It'd be negative what? 32. Last but not least, I have D. Negative 27 divided by 3. What's that? 3. Something higher. Not 4, not 3, something higher. Negative 9. So negative divided by a positive is a negative, and 27 divided by 3 is just 9. Questions on this? Any one of these? Good? All right. This is kind of common sense. This next part. So anytime you multiply something by -1, it's going to give you the opposite, right? So -1 times -6 is +6, and -1 times -3 is -3, right? So multiply by -1 changes the sign. Next, let's talk about expressions with integers, right? So what happens when there are more than 2 numbers in an expression? The order of operations still applies when negative numbers are included. So remember, please excuse my dear Aunt Sally, right? Let's try some examples, right? We simplify the expression that use all 4 operations with integers: addition, subtraction, multiplication, division, and then that's it. That's how we do this. So check this out. I'm going to show you something before I tell you the trick, all right? Because there's a trick to this. I have -2 to the 4th power. Here's what it literally means. It literally means -2 times -2 times -2 times -2. That's exactly what it means, right? So now a negative times a negative is a positive, and so I'm just multiplying these two together. So this is going to become what? +4 times -2 times -2, right? Now, a positive times a negative is a negative, and 4 times 2 is 8, right? So this is going to be -8 times -2. Add them together, what do I get? Multiply them, I'm sorry, what do I get? 16 flat. That's my answer. All right? Okay. Let's look at B. Now pay attention to B. B is a little different. All right? This is -2 to the 4th power. What does that mean? That means -1 plus 2. I'm sorry. Why did I say plus? I'm like throwing myself off. It means -1 times -2 times -2 times -2 times -6. Whoops. What am I talking about? -2. I'm sorry. I'm like dazing out right here. So multiply these straight across, right? We already know what -2 times -2 times -2 times -2 is. We did that above, right? That's going to be +16. But I'm sorry, let me erase this. I'm like bugging out right now. But I still have that -1, which is going to flip the sign to give me what? -16. The negative just ensures that it'd be negative. Yeah. The key difference here is that parentheses, right? This is why we want to use parentheses, right? Negative 2 in parentheses to the fourth power is repeating negative 2, but negative 2 to the fourth, it repeats the 2, but not the negative. But the negative comes out in the end, right? So this is why we need those parentheses. This is something that I would more emphasize in the calculator portion of the class, but just so you guys can see that now, right? The difference and why we use the parentheses. A little worried about time, so I'm just gonna move on from this, but you guys get the idea, right? Behind this. There's practice inside of this packet that I gave y'all, so it's not like I'm moving on, you're not gonna get to see this again, right? The last example showed us the difference between negative 2 to the fourth and negative 2 to the fourth, right? This distinction is important to prevent future errors, right? The next example reminds us to multiply and divide in order from left to right. So remember, when you're doing your order of operations, please excuse my dear Aunt Sally, always you do it from left to right, all right? So let's take a look at this real quick. I have like a minute, but if y'all could just give me 5 more minutes, I'll just wrap this up real quick, right? So let's look at A. I have 8 times negative 9 divided by negative 2 cubed. Now, again, first thing we want to do is what you call it, like our order of operations. So there's no parentheses to do, right? But there's an exponent, negative 2 to the third power. That's what we should do first. So this becomes what? 8 times negative 9 divided by, this is going to be what? Negative 8. Again, that's just negative 2 times negative 2 times negative 2. All right. Now, to answer this, I want to go from left to right. From left to right. So I have 8 times negative 9, which is 72, I think. Negative 72, excuse me, negative 72. And then divided by negative 8. And then a negative divided by a negative, we know is a positive, and 72 divided by 8 is just 9, right? And that's it. That's how we do this. So just remember to go from left to right. Let's look at B real quick. For B, I have negative 30, excuse me, divided by 2 plus negative 3 times negative 7, right? Again, from left to right. But remember, we want to do multiplication division first before we do addition, right? So negative 30 divided by 2, that's going to give me a negative 15 plus negative 3 times negative 7 is going to give me a positive 21. Negative 15 plus 21, that's going to be 6, right? And then that's it. Thank you. Yeah. Questions on this? Anybody? Good? All right. We're going to reconvene after lunch, right? Yeah, we are. But I'm not even sure if I'm going to be the one you're reconvening with. I hope I am. All right. So let me just do this last part. This is going to be really, really simple. Just kind of taking a leap from integers and we're jumping into algebra for a quick second, right? So we're going to be evaluating variable expressions with integers. So remember that to evaluate an expression means to substitute a number for the variable in the expression. And now we can use negative numbers as well as positive numbers, right? So this is kind of getting into the applied math and computer science realm right here. All right. After this example, I'm pretty sure you'll understand what I'm talking about, right? So let's look at this example. So I want to evaluate, I want an actual answer to come out of this. 4x squared minus 2xy plus 3y squared when x is equal to 2 and when y is equal to negative 1. So what am I going to do? And the expression right here, 4x squared minus 2xy plus 3y squared, I'm going to plug in the values for x and the values for y. And then after that, I just do the math on it and I get my answer, right? So let me rewrite this. This is going to be 4, but instead of x, what is x? 2 squared minus 2 times, what's x? 2 times y, which is -1, plus 3 times -1 squared. All right, did I lose anybody with that first step? Right, all I'm doing is I'm plugging in for x and I'm plugging in for y. Everywhere you see a variable, give me a parentheses and then plug in that number there, and then it works. All right. The rest of this is just math, nothing crazy. This is 4 times 4. You want to do the exponents first, of course. Minus 2 times 2 times -1 plus 3. -1 squared is just +1. Now we want to do our multiplication, right? 4 times 4, that's 16, minus a -2 times +2 is going to give me a -4. -4 times -1, +4. And then plus 3 times 1 is 3. After that, just add them together, right? So this is like what, 23. And then that's it. Questions on this, all right? So I'm going to give you an expression, give you the value of the variables in the expression. You're going to take them and plug them in, a little bit of math, then we're good to go. All right? And that's it. I do have other stuff to show you, but we ran out of time. All right? So we'll stop it right there. You guys can go get